morning, everyone. Welcome to Right Academy, and this is a revision in physics, and specifically on forces or Newton's second law, as well as third law. So, if you are new to this channel, please subscribe for more information. So, the first question says, what resultant force produces an acceleration of 5 meters per second squared in a car of mass 1000 kg? Okay, so they are looking for an acceleration. Okay, so what you need to collect, you need to collect the data, and we have been told that the resultant force, so which we can just say force R, where the R is resultant. So that's what you're looking for. And the acceleration is just 5 meters per second squared. And the mass, which is M, is 1000 kg. So now we know that the formula for finding the force applied or produced on an object is just F equals to mass times acceleration. And this is going to be, the mass is 1000 kg, okay, multiplied by the acceleration, which is 5 meters per second, or just you can even say that this is 1000 multiplied by 5 Newton per kg, and this is going to be the kg goes, okay, and you're just going to have 1000 multiplied by 5 Newton, and this will be just 5000. So that is the force, the resultant force produced. Okay. Now we move on to the second question, which is B. What acceleration is produced in the mass of a car by resultant force of this 30 Newton? Okay. So in B, okay, so on B we are saying that they are looking for the acceleration, and then the resultant force, okay, is just 30 Newton, and the mass has been given as 2 kg. So again, this will be very simple, just a matter of saying the force resultant is equal to the mass multiplied by the acceleration. And this will be, now we are looking for the acceleration, so we make A the subject, we divide both sides by M, both sides by M, and this goes. So meaning your A is just going to be force resultant over the M. Okay. And we know that the force resultant is 30 Newton divided by the mass which is just 2 kg. 2 kg. Okay. And this is just going to be when you divide, this is just going to give you 15 Newton per kg, or just 15 meters per second squared. Okay, so that is the answer on question 3b. Now we move on to question 6. Question 6. What does an astronaut of mass 100 kg weighs? Okay, weigh on Earth, where the gravitational field strength is 10 Newton kg. Okay, so in this case again, you have to correct the information. Okay, so from there we are going to say that the mass, which is just m, is just 100. And then the gravity, meaning acceleration due to gravity, so you can just say A is equal to G equals to 10 Newton per kg. Okay, and then now they are asking us to find what? So what does an astronaut of mass? So we are looking for the weight, which is just that. So having those details, now we can say the weight of an object is equal to the mass multiplied by the gravity. And this weight is going to be, the mass is 100 kg multiplied by the gravity. So on Earth, sometimes this 10 is just written as 10 meters per second squared. Okay, so from there, this is Newton per kg, and this is going to be just the kg, and kg goes, so you have 100 multiplied by 10 Newton, and this will give you 1,000 Newton. Okay, so that is the answer on question 6A. Now let's move on and again go to B. So what does B say? So they are saying on the moon. So this is on the moon where the gravitational field strength is 1.6. So again we are looking for the mass, for the weight of this object. Okay. So how much is it going to weigh? Okay. So what this implies is that again, now the acceleration due to gravity is just changed to 1.6 Newton per kg, since we are now on a different space, which is the moon. So the formula will stay the same. This is weight equals to the mass multiplied by gravity, and this is going to be, the mass is still from here is still 100 kg. So 100 kg multiplied by the gravity onto the moon, and this is going to be this, and this goes. Okay. When you get your calculator now, this is just going to be 160 Newton. So just to say something, when you compare the two weights, this 1,000 Newton and this one, is that the higher the gravity, the higher is the weight of that object, and the lower the gravity, the less the object weighs. So conceptualize that, okay? Because weight is different on every space or region that you take it to, okay? So now we move on to the last question, which is question 7. Now question 7 says, a rocket has a mass of 500 kg. A, what is its weight on Earth? So on Earth, the acceleration due to gravity is 10 Newton per kg. So what is its weight? Okay. So from there, you always collect the point, or rather the information. So from this one, the information is, okay, the gravity acceleration due to gravity is just 10 Newton per kg, okay, and the mass is given as 500 kg. Now we are looking for the weight. So this is, you know, the formula for weight is weight equals to mass times gravity. And this will be now, the mass is 500 kg multiplied by the gravity, which is 10 Newton per kg. And this is going to be the kg. Kg cancels. The units of weight is Newton. So this is just going to be 5,000 Newton. Okay. Now what about B? On B, now we have at lift off, the rocket engine exerts an upward force of 25,000 Newton. What is the resultant force on the rocket? And finally, what is its, okay, so what is its initial acceleration? So we are looking for two things. So the resultant force and also the acceleration. Okay. So we have been told that this rocket has got the force at lift off. Okay, so this is a Newton third law. So force at lift off is 25,000 Newton. And the other information is that the mass, okay, so we have already, we know the mass, which is just 5,000. Okay, so the mass is 500, sorry, 500. Okay. Okay, so now what you need to understand is that a rocket has a mass of this. What is its weight? Okay, so there is the weight. Imagine that, let's assume that this is in quantum physics, this is a rocket. So let's say this is just a rocket. So now if the rocket is sitting down on the ground, now it is pulling, it is exerting downward force, which is the weight, and this is what we have just found, which is just the 5,000. Okay. Now when the force has to lift off, okay, meaning the upward force was found to be 25,000 Newton. Okay, so I need to find the resultant force. Now this force is downward and the other one is upward. So what you need to do is resultant force, meaning R, will be equal to the upward force, because that is a larger force. So upward force minus the weight. Okay, so from this, resultant is going to be 25 Newton minus 5,000 Newton. Okay, now once you do that, you are going to have 20,000 Newton. Okay, so this is the force that caused the motion, and we have to apply this force in order to find the answer. Okay, so from the question, if you go back to the question, is now they are asking us what is the resultant force on the rocket and what is the acceleration. So now this is the resultant force, okay, and therefore the acceleration, first of all, you say force resultant is equal to mass times acceleration. So we make acceleration the subject by dividing both sides by this. And this is going to be A equals to force resultant divided by M. Now we know that force resultant is 20,000 divided by the mass, which is from the information that we have, the mass of the rocket is 500. And this is just going to be this. Therefore, when you do this, the 2 zeros goes, 2 zeros goes. So we have 5 into 20 is 4. And this will give us 40, okay, Newton per kg. Or, therefore, the acceleration is just 40 meters per second square. Okay, so this is the answer. Thank you so much for watching. If you like my videos, if you love this work, please support me by subscribing so that you're able to receive more information. You can also share to your relatives, your families and friends. Thank you so much. This is Radko Kadem, and this is Professor Wadamai.